Why do we need to connect a diode in series when using solar panels to charge a battery? What is the function of this diode? Today, I'll share through an experiment the reasons behind it. First, let's test what happens without adding a diode. This is a solar panel and this is an 18650 battery holder. Connect the positive terminal of the battery holder to the positive output of the solar panel and connect the wire to the negative terminal of the solar panel, using the ends of the two wires to connect an ammeter in series. This is an 18650 lithium battery. Place the battery in the holder. Take out the multimeter, switch to milliampere current range, and then connect the multimeter to the two wire ends. In this way, you can connect the multimeter in series to check the circuit current. Under sunlight, the ammeter shows a reading of 1.3 milliamps, which is the battery's charging current. Next, we flip the solar panel upside down, and at this point we can see a negative current, indicating that the battery is supplying power to the solar panel in reverse. When the solar panel is flipped back and exposed to light, it becomes a positive current again, showing that the solar panel is charging the battery. From this, we know that when there is light, the solar panel charges the battery, but when there is no light, backflow occurs, with the battery supplying power to the solar panel, which wastes energy and might damage the solar panel. Therefore, we need to connect the diode in series in the circuit. When there is light, this diode does not affect our charging, and the current is 0.8 milliamps. Then, when we flip the solar panel, there is no current. It won't show a negative current like before. With this diode, it can prevent reverse current when there is no light, or the light is poor, protecting the solar panel from damage.